For decades, fundamental physics has been stalled at a strict boundary. General relativity predicts a universe defined by perfectly smooth, predictable, continuous manifolds, while quantum field theory demands a reality built upon jagged, unpredictable, discrete integer states. When the continuous collides with the discrete, the mathematics break down. To resolve this, we look to the theory of infinity. It operates on a radical premise. The universe is not assembled from fundamental, discrete building blocks. Instead, it is carved out of an infinite, undifferentiated substrate. This structure is expressed through a strict triad. The infinite substrate represents boundless potential. A generative constraint acts upon it to break the primordial symmetry. This carving process results in the emergent finite, a highly stable, bounded knot of physical existence. Our strict objective here is to execute a rigorous mathematical ledger audit of that continuous, discrete boundary. We will do this by visualizing what happens when stable geometry is forced past its thermodynamic limits, a process known as the rung 10 complex ejection. If physical existence is equivalent to mathematical self-consistency, then accurately calculating the exhaust of this ejection will reveal the absolute topological constraints, the exact shape of our reality. This diagram plots the foundational, stable baseline of the universe. We map this using the light witness equation, defined as sine of x equals sine squared of x plus cosine squared of x, which isolates the primary spatial footprint of the golden set. When we algebraically isolate the discrete geometric anchors of this wave, the mathematics force one root entirely into a non-physical complex branch. It is prohibited from existing on the real number line, leaving only the principal light root locked strictly at τ/2. This primary root operates in tandem with a secondary equation called the dark witness. The dark witness is a strictly monotonic, parity-fractured integral manifold. Because the function is strictly monotonic, it generates a singular, inescapable zero crossing, allowing us to isolate a unique numerical dark root coordinate. By combining the principal light root with this unique dark root, we formulate the dark ORC ordered pair. We then apply a specific fractional Fourier derivative to these coordinates. A fractional Fourier derivative is a mathematical operator that generalizes standard derivatives to non-integer orders. In this model, it induces a precise π/4 phase rotation, establishing the strict Dirac constant. Mapping this baseline proves that the physical phase of the universe is mathematically rigid. We now have the exact coordinates needed to see how this space reacts when subjected to impossible geometric weight. We test this geometry by taking the constant boundary of the light witness and applying an artificial shift. When this mathematical stress is introduced, the real physical phase of the universe exhibits extraordinary rigidity. It refuses to alter its geometric coordinate, permanently locking its spatial position at π/2. This behavior exposes the phase amplitude ejection law. The actual spatial geometry remains mathematically immune to amplitude scaling. Because the real spatial dimension refuses to absorb any of the artificial boundary shift, 100% of the newly introduced geometric mass is immediately rejected. This rejected geometric mass does not disappear. Instead, it is violently vented directly into the imaginary y-axis amplitude. The universe actively protects its real spatial coordinates by forcing any excess mathematical tension directly into unseen complex dimensions. This image maps the stable 1D physical plane just before we trigger the mathematical transition necessary to force the trigonometric polynomial into pure complex topological exhaust. We execute a subtractive ejection. We bypass all intermediate boundaries and hit the manifold directly with massive rung 10 Fibonacci coefficients, specifically demanding the space absorb a negative 233 shift. This introduces a massive deficit of geometric weight. The equation's discriminant evaluates to a violently and completely shatters. The spatial roots are forcibly thrown entirely off the physical line, ejected deep into the complex Weierstrass phase space. Because the originating Fibonacci coefficients are massive, this topological stress requires advanced algorithmic resolution to read the resulting phase data. The destruction of the 1D plane is not a mathematical error. It is a strictly governed mechanical venting process that ejects perfectly conserved geometric data outward into the complex plane. This animation models the Weierstrass substitution, the necessary algorithmic tool to unpack this chaotic, complex phase space. The Weierstrass substitution maps continuous trigonometric wave ejections onto the real projective line, converting them into solvable algebraic polynomials. When we run the nested chaotic solver on this converted data, the output reveals the literal algorithmic exhaust of the universe. Hiding inside the imaginary phase of this specific equation are two repeating rational fractions, 131 over 89 and 2 over the square root of 5. Decompiling the first of these two fractions will definitively prove the mathematical behavior governing the continuous discrete boundary limits. We focus entirely on the isolation of the first fraction, 131 over 89. We process this through the normalized discriminant formula. This formula dictates the inverse squared discriminant space for any characteristic equation governed by Fibonacci sequence boundaries. By dividing the discrete rung 10 integers by their structural scaling factor, we extract an exact decimal of 1.47191. Compare this to the Euler equations for thermodynamics, which explicitly bottom out at the continuous 4 over e limit, or 1.47151. Calculating the log residual gap between our discrete mathematical extraction and the continuous physics law reveals a difference of approximately 0.0002. Under the strict mathematical auditing of the friction versus fiction protocol, we define this tight residual gap as a thermodynamic mirage. The discrete state of 131 over 89 is not a sloppy approximation. The log residual represents the inherent mathematical friction generated by crushing randomized integer space back into a continuous boundary. This friction warps the spatial geometry just enough to deceptively shadow the Euler thermodynamic constant. At this exact geometric rung, the discrete integer matrix flawlessly synthesizes the mechanics of pure continuous fluid physics. Now we move to the second fraction extracted from the algorithmic exhaust, 2 over the square root of 5. This fraction defines the exact, immutable geometric architecture of the golden manifold itself. The structural relationship between these two fractions is strictly governed by integer arithmetic. Evaluating the exact mathematical difference between the primary phase output and the embedded parameters of the secondary phase yields a pristine whole number, 31. This establishes an irrefutable topological transport law. The secondary internal phase shadow of a fully ejected Fibonacci polynomial is universally exactly 31 units larger than its complex discriminant. To ascertain the continuous limit, the entire structural system must be extrapolated upward to absolute continuous infinity. By applying the integer transport law at the asymptotic limit, the ratio of sequential Fibonacci integers converges perfectly. The continuous limit rail for the secondary fraction mathematically reduces to 2 multiplied by the quantity of phi minus phi. This integer transport law provides a mathematically rigorous bridge. It allows us to scale the mechanics of a shattered finite 1D plane directly up to the continuous infinite architecture of reality. Evaluating the transcendental constant of that continuous limit rail yields an exact continuous decimal of 0.894427. Comparing this absolute continuous limit rail against the raw extraction obtained from the complex phase solver at rung 10 exposes a log residual gap of just 10 to the negative 12th. This value represents exactly twice the spatial distance spanning the void between the golden ratio, phi, and its conjugate root, phi. We define this value explicitly as the double golden mass. It serves as the absolute topological diameter of the golden set. This sequence synthesizes the master theorem of continuous discrete topology. The boundary is fully computable. When continuous trigonometric manifolds shatter under massive discrete shifts, the mathematical space does not devolve into chaotic anomaly. The algebraic exhaust of the complex plane meticulously conserves the total topological mass of the system. The physical constants of reality are not random insertions. They are the exact invariant mathematical tension generated at the boundaries of the infinite.